Hello everyone, welcome back to Code of Management. In episode 1 of this Agentic AI engineering playlist, we have actually discussed about the basic understanding of what is Agentic AI. So we understood that generative AI mainly generates the content or answers, while Agentic AI basically designed to work toward a goal. That's the difference between the generative AI and Agentic AI. So we also discussed like some important concepts like LLM, AI agent, tools, memory, state, planning, actions, right? So today we are going one step deeper. So today our topic is like how does an AI agent actually work? So we will understand the complete agent loop. So the basic idea like how it will understand the goal, it observe, then try to reason, then plan, act, then whatever result got. So observe that result, then reason again, and continue or finish. So by the end of this episode, you will have a clear understanding of how an AI agent works internally. So let's start. First of all, I'm giving one example. So let's take a very simple example. Suppose I ask an AI agent like find the sales for customer ABC for the last month, okay, and tell me whether sales increased compared with the previous month. But initially, break it down. Like, first of all, think about this problem. Like, find the total sales for the customer ABC for the last month. So it sounds like a simple question, like, but let's think about what the AI system actually needs to do. So first, it needs to understand the question. Then it needs to understand, like, who is customer ABC? What does last month means? Where can I find the sales data? So maybe the data is stored in a database. So the agent needs to use a database tool. Then it gets the result. Finally, it gives the answer to the user. So the flow becomes like user will ask the question, then it will understand the goal, find the required information, then it select a specific tool like database tool or some API or something like that. It will execute the tool, then get the result, understand the result, and finally it will give you the final answer. So now understand the high level agent architecture. So the agent is more than an LLM. Okay. Like uh, an AI agent is not just an LLM. So an LLM is an important part of the agent. I have given example like LLM can be a brain like that. But agent is whole human body like structure. So we need other components as well to build the agent. So whenever there is one agent, so it will direct the instructions via LLM, but it has some other things as well, like tools, memory, state. So the LLM is mainly responsible for understanding and reasoning, but tools allow the agent to interact with the external systems, like through APIs or DB, context, okay, context search, like that. And memory helps the system remember useful information, like the history. So there can be long-term memory, short-term memory as well. Like in our brain, we have the long-term memory and short-term memory, right? Like that only. Now the state basically helps the system to understand like what has already happened in the current task. So together these components create an agentic system. Now, first of all, we will understand what is the goal. So step by step, actually, we will understand. So first of all, just understand what is the goal. So let's take our example again. So the user says, find the sales of the customer ABC for last month. So the first thing the agent needs to do is understand the goal. So the goal is like find the sales. for customer ABC for last month. So the agent needs to identify the customer as ABC, data as the sales data, and time period is for the last month. So this is the very first step. The agent needs to understand like what does the user actually want. Now the second step is reason. Like reason about what is required, right? So the now the agent needs to think about what is required. The agent may ask internally, like where can I get the sales information? Maybe the answer is the sales data is available in a database. So the agent knows that it needs a database tool. So the important point here is the agent is deciding what should happen next. For example, there was some user goal was there, right? So it will think internally like what information do I need? Where can I get it? Which tool can provide it? So this is the reasoning part. Like when we will get some task, we actually think, right? That what I need to do, from where I can get some help, where from where I can get some information. So that thinking approach is the reasoning actually. Next thing is after the thinking, after the reasoning, the next step is planning. So for simple tasks, the plan can be very small. For example, like find the customer ABC, get last month's sale, return the result. But for a more complex task, the plan can have many steps like find the customer, check customer status, get current sales, get previous sales, compare the sales, calculate the percentage, prepare the report. Next is select a tool. Now the agent knows that it needs sales information. Suppose we have these tools like available tools are like search customer, get customer sales, calculate percentage, send email, create ticket. So which tool should the agent use for our current task like get customer sales? Okay. So the agent selects that tool. The tool may require some input. For example, in the get customer sales, we can pass the parameters like customer as ABC and period is for the previous month or last month. So this is called actually the tool calling. Now in detail, like what is the tool calling? So tool calling is one of the most important concepts in agentic AI. The LLM can decide like I need to call the sales tool, but the LLM should not directly access our database without controls. So instead, the application receives the request. The flow is like there will be some LLM decision, then there will be some tool name, then there are some tools, arguments or structured arguments. Then application executes the tool and tool result returned. So for example, suppose we are using the get customer sales this method, okay? And we are passing these arguments. The customer ABC and period is the previous month. So the application executes this function and then the result comes back. Then we will get the proper output. Suppose the database returns like customer ABC, orders something like that. Okay, suppose here what input we have given customer and period. These parameters we have passed, right? Now the output is we are getting like orders as 37, total sales is 4,85,000. So now the agent has new information like this is called an observation. So the agent observes the sales data and orders. So now it can decide like I have enough information or maybe like I need more information. So this is where the agent loop becomes important. So see here the executions of the tools happen like the agent will use this get customer sales. It will fetch the data from the database through the query and result we are getting like that. So this is the observation. Okay. Now see the complete agent loop. So the basic agent loop will look like that. Like there will be some user goal, then observations, then reasoning, then planning, select the tools, executions of the tool, again observations. We'll check goal has been completed or not. If no, then replanning is required, then continue. Like here, it will come into this step, replanning, and again, the further steps will be done. And if goal completed, then yes, and we will get the final answer. Okay. So there can be two-step, multi-step examples. Like let's make the like just make it more important, interestingly. Like suppose the user says, what our earlier query, this one, just see, very old one, this one, like find the total sales of customer ABC from the last month and tell me whether sales increased compared with the previous month. Suppose this problem given to the agent. So now the agent needs two pieces of information. First of all, it will ask for the this month's sales, like current month sales, and it will check the last month's sales. So the agent may do like there will be some user request, and then it will understand the goal, then get this month's sales, then it will check the result, then it will get last month's sales, get the result, compare between two results, and we will get the final answer. So suppose this month sale, suppose 5 lakhs, last month sales 4 lakhs. So increase is 1 lakh. So percentage will be calculated according to that. Okay. And we will give the result like customer ABC sales increased by approximately some kind of percentage compared with the last month. So just notice what happened. The agent performed multiple actions to answer one question. So that is basically the agentic behavior. See here the multiple step. My order has not arrived. Check it and arrange the appropriate resolution. That is the problem user is giving. Then it understand the intent. Then it find the customer. It find the order. Check the shipment. Observe the status. Check the policy. Decide the resolution. Do the refund or replacement or escalations and notify the customer. And see, there are multiple APIs also involved, like customer API, order API, tracking API, knowledge base, refund API, ticketing system. So if the shipment is delayed, the agent can inspect the policy and determine whether to explain the status, issue a refund, create a replacement, or escalate. Next thing is like state. So during the agent execution, state is a very important factor. So the current state could look like this, like customer verified is true. Okay. So order found, suppose true, shipment checked, shipment status, policy checked, resolution. So these are the things. So these information tells the agent like what has already happened. So without state, the system could not uh, understand like what has been happened already. It will lose the track of the task. For example, it might check the customer again, even though the customer has already been verified. So state helps us track progress. Now there are differences between the memory and state as well. So don't confuse about this memory and state. Okay. So basically they are related, but they are not exactly the same. State is like for current task progress. Like the shipment status is delayed. That is one state. Short-term memory can be divided into two types, like short-term memory and long-term memory. So short-term memory is like current conversations or context, and where the example is like recent user messages. And long-term memory like persisted useful information, like user preference or historical fact, like this customer prefers mobile rather than laptops, like that. Okay. So state basically is like what is happening now, and memory is basically what useful information do we remember. And according to that, futuristic task can be easy. Suppose the tool fails. What happens then? So that is a very real world problem in the systems. So what happens if the database is down? What happens if an API takes too long? What happens if the tool returns an error? So an agent cannot assume that every tool call, like whatever tool calling will be happen, that will succeed. Cannot assume like that. So for example, there is an agent, it's calling the API timeout happened. So failure detected. So it will be retried. So then if yes, then again retry. Then no, then fallback or human intervention will be required. Now the agent or application needs to decide like what to do. Maybe retry. Through the retry we can get the success, or maybe use another service. Like suppose primary API is there, failure happened, then need to use some fallback API to get some instant response, or maybe ask a human to intervene into that. So production agents need the retry logic, timeouts, error handling, fallbacks, logging, monitoring. Those are required. Now, we will also know that why the retries are also important. Like here we are doing retry. So let's say the agent calls a payment service. So the request fails because of a suppose temporary network problem. So we don't necessarily want to immediately stop the whole workflow, right? So we may retry. But there is another important point, like we should not retry forever. For example, suppose attempt one failed, attempt two failed. Again, we are retrying, attempt three failed. So then we can do like we can do some fallback, or we can involve some human to review it. So this is important in production systems. And during the retrying, there are some features we can implement, like exponential back off. But I have already discussed in the system design playlist. Okay, you can go there. You can search for episode number 9 or 10 like that. So there you can see those concepts. Then retry counts are required. How much retry counts we can do if it will reach the highest count, what we will do. Those concepts I have discussed in the system design playlist. Next is like when should an agent stop? So an agent needs to know when it should stop. So there are several possible reasons, right? Like suppose just consider case one, like goal completed or not. If goal completed means like if we will get the final response, then we the agent can stop this. Next is like uh, tool unavailable. So suppose tool failed, so we cannot continue. We have to involve one human or like some fallback response. Some missing information, suppose. Okay, like maybe the agent needs more information from the user. Like which customer do you mean? If I will ask like for customer ABC, do this, then it can be like that, like it will be unaware about that customer. So it needs to know like for which customer um, it's actually asking. The agent can ask for the clarification. Then for safety concerns as well, like maybe the agent wants to perform a sensitive action. So the system may say like human approval required. So the agent stops and waits. So for those cases, actually the agent will be stopped. Okay. Next is human in the loop. So this is very important for enterprise AI. So we don't want an AI agent to have unlimited permission. So suppose an agent wants to delete a customer account, or transfer some money, or deploy to production, approve a large payment, change important business data. So we may require human approval for that. So the workflow becomes like it will be agents, then plan the action, approval required. If no, then execute. If yes, then human review. Then human can approve or reject. If approve, then continue. If reject, some fallback response, or the process will be stopped. So this is called the human in the loop. So it gives us a balance between the automation and control. Now, agent loop versus normal workflow. So now let's compare a normal workflow with an agent. So a normal workflow might look like, suppose there are multiple steps. So one by one, the steps will be done, like step A, then step B, then step C, but step T, step D. So the developer decides the complete path. But for an agent, when agentic loop is there, so there an agent can be more flexible. Like there will be a goal, then agent will understand the goal, then agent will take the decisions. then it will take the help of some tools, it will observe, then the proper decisions will be taken, then it can take some another help of tools, then it will again observe and again take the decisions and finish the process. So like if you will see the difference, like see the path. So agent loop versus fixed workflow. So here path is mostly predefined, but agentic loop can adapt to observations. Next is decision point. So fixed workflow is developer defined, but agentic loop can dynamically select next action. Next is tools. So it is explicitly wired. Then here it is selected from available capabilities. For loops, fixed workflow usually predefined, but for agentic loop can replan dynamically. Then control. It's highly deterministic, but for agentic loop it requires like guardrails and boundaries. Now you also need to know that agents are not magic, right? So there is one very important engineering point, like we should not use an agent for everything. Like if the workflow is simple and predictable, a normal workflow may be better. Like suppose some receive order, okay, for order management system, suppose first of all it will receive the order, right? Then it will check the orders, like validating the order, then charge the payment, then create shipment, send email, like that. There the fixed workflow will be better. But if this process is always the same, we don't necessarily need an autonomous agent. So a deterministic workflow can be easier to test, easier to monitor, more predictable, less expensive. So agents are more useful when the system needs to make decisions dynamically. So just one simple agent from scratch, just see that code snippet. So just look at a conceptual implementation. So we can imagine something like while not task complete, then context get current state, then decision, then LLM. So their goal, context, available tools, and if decision dot type is tool call, then result will be like execute tool. Their decision dot tool, then decision dot arguments, update the state. Else if decision type is final and return decision dot response. Else handle invalid decision. So just understand this in simple terms. Like first, it gets the uh, current state. Then ask the LLM what should happen next. So if the LLM wants to use a tool, then executing the tool, then update the state, right? And then go back to the LLM. And if the LLM says the task is complete, we return the final answer. So this is the basic idea behind an agent loop. Okay. So this is a conceptual loop. Production implementations also requires schema validations, authentication, authorizations, timeouts, retries, logging, observability, and safety controls. Now, just see the another example, like two tool calls. Like suppose compare ABC sales this month with last month. That I have already told, but see again. Just goal, then need current month plus previous month sales. So first of all, tool call one through the get customer sales method. Then there we are passing the ABC and we are passing the time as like current month. We are then we are getting the results. Then that is the observation. When we are getting some result from a tool calling, that is the observation. So there it is suppose 5,20,000. Next tool call two, we are calling the same method. We are passing the customer as ABC only, but the time frame we are giving as previous month, and we are getting some observation like 4,85,000. Then it will reason. Then final answer is sales increased by approximately 7.2%. So the agent uses the output of multiple tool calls to complete a single user goal. Okay. So next we will know like what does the agent controller do? Like what are the agent controller responsibilities? So let's summarize like the responsibilities of the agent controller. So it can receive the user's goal, it can maintain the current state, it give the LLM the required context, provide the available tools, receive model's decision, right? It also can validate the tool calls, whatever request will come, then execute the tools, then store the result, store the observations, handle the errors, apply security rules, apply retry at timeout policies, enforce authorization and guardrails, return the final answer. Okay, so the model decides, the application controls the execution. So very important engineering principle, if I will tell. So that is basically the model basically decides and the application controls execution. What does this mean? So the LLM can say that call the refund API, but the application should check, is this user authorized? Is this action allowed? Are the arguments valid? Does the user need approval? Or is the amount within limits or not? So only after validation should the application execute the action. So this is extremely important when building production agents. So some important interview questions are like what is an agent loop? So an agent loop is like repeated process where the agent observe information, reasons about the next step, performs an action, observe the result, and continues until the goal is completed. Next is what is tool calling. So tool calling allows an AI model to request the execution of an external function such as database query, API call, search operation, or calculator like that. Next, like why is an LLM not enough to build an agent? So an LLM provides reasoning and language capabilities, while the complete agent also needs tools, state, memory, execution logic, control, and safety mechanisms. So next, it like what is agent state and why do agents need state? So state basically helps the agent remember what has already happened during the current task and decide what should happen next. And also we have discussed like difference between the memory and state. Again, just I'm telling, like state represents the current task progress, while memory stores the useful information that may be needed across interactions or future tasks. Next, why do agents need stopping conditions? So stopping conditions prevent infinite loops, unnecessary tool calls, higher costs, repeated failures, and unsafe actions. Next, why is human in the loop important? So human approval is useful for sensitive, high risk or high impact, expensive or irrelevant actions. So just let's quickly summarize today's episode. So we learned that an agent generally works like a proper flow. There should be a goal. It will understand the goal. Then it will reason about that. Then it will plan the actions, select the tool, execute, then observe the result, update the state, then reason again, continue, and then finish. So you also learned like LLM provides reasoning and language capabilities. Tools allow the agent to interact with the external systems. State tracks the current task. Memory stores the useful information. Agent loop allows repeated reasoning and actions. And human in the loop basically provides control for important actions. So, and finally, the application should control the execution even when the model decides like what action may be useful. Okay, so that is the episode 2 for this agentic AI. So in episode 1 we learned what is agentic AI, and in episode 2 we learned how does an AI agent actually work. So in the next episode we will discuss agent architecture patterns. So we will maybe cover like what is React, then plan and execute, reflection, router, sequential workflow, parallel workflow, human in the loop, supervisor pattern. So you will understand when to use each pattern and we will compare them using real world examples. So if you are following the Agentic AI engineering playlist, I recommend watching the episodes in order because each episode builds on the previous one. So this is code tab management. Thank you for watching. See you in the next episode. Till then, stay tuned and do like, share, and subscribe the code tab management for motivating me to build such informative videos. Thank you, everyone. Bye.